Hello and Assalamualaikum to my panel. My name is Mohd Amirul Amin bin Rahimi, student ID 2019 5282 and 71. So today I want to present about my final year project, which is 601. My topic is analysis of fluid flow over a flat plate. So my supervisor is Nur Melissa binti Ali. So first of all, project summary. This project is carried to study the flow of fluid over a flat plate. And then the method of the project is to use engineering simulation, commercial tools, which is ANSYS Fluent and CATIA. So all the data and the simulation present in terms of contour and graph. Next is problem statement. The study is conducted to investigate the fluid flow and boundary layer thickness on the rough surface of flat plate in order to obtain the screen friction, mass flow rate, velocity contour, and others. And then the study, this study is carried on for a laminar flow boundary layer. Next, I go for objective. First is to study the effect of surface roughness on the development of the boundary layer. And then next is to measure the boundary layer properties for the measure velocity, profile, and pressure. For scope of work and limitation, the aim of this research is to investigate the variant of boundary layer thickness over a flat plate. The study will be focusing on the behavior of layer thickness or boundary layer thickness with different surface configuration. So for the limitation for this research is only for laminar flow, and the velocity used is only 1 meter per second. So this is the methodology for this research. First of all, create 3D modeling flat plate in CATIA, and then simulate 3D CATIA flat plate into ANSYS Fluent. Next is input the boundary condition and all the parameters, such as the density of air, the velocity, and others. And then observe the boundary layer of the flat plate. Lastly, result. So this is the geometry model for flat plate. The size of the flat plate is 390 mm times 300 mm times 600 mm. So this is the geometry model that has been created in using CATIA V5. So for computational fluid dynamics, this research will use ANSYS Fluent software as an engineering tool to run the analysis. So for each, I consider fluent, which is inlet, outlet, wall, and top. So, the energy equation was turned off and the flow is laminar. The fluid used is air, and the density of air is 1.225 kilogram per meter cubic. So this is the parameter that has been used. First, velocity inlet, which is 1 meter per second. For the outlet pressure, no. And then number of iteration is 300. For turbulent intensity is 5%. Density air 1.225 kilogram per meter cubic. And then the flat plate is no slip. For viscosity is 1.7898 times 10 power of -9 kilogram per meter second. So for the preliminary result. So the grid independent test must be done to define the number of elements that could have closest to the experimental result. So there are three in grid independent tests, which is coarse, medium, and fine. For the fine mesh is picked as a final mesh to run the simulation because fine mesh has greater number of elements compared to others, although it has longer time to mesh. So for validation result, there are 4 steps. First is geometry, and then second is mesh, third is setup, and fourth result. Geometry is create a geometry model for the flat plate. Meshing is to mesh the flat plate, and then setup is include all the parameter, and then fourth is result. So this is my expected result for this research, and to find, first of all, is mass flow rate. The mass flow rate is decreasing for about until negative 0.005, and then is constant at 0. So this is the skin coefficient of friction that has been obtained using axis fluid. And then next is the velocity contour, which is show the boundary layer thickness of the flat plate, and also pressure contour. I think that's all from me. Thank you.